Hi, I am Dr. Harish Ken, Assistant Professor, Department of Chemistry, Dayanand Saha College of Engineering, Bangalore. Welcome to this session on photovoltaic cell. At the end of this session, you'll be able to explain what is photovoltaic cell. You'll be able to explain the mechanism of PN junction. You'll be able to understand the construction and working of photovoltaic cell. You'll be able to enumerate the advantages, disadvantages, and applications of photovoltaic cell. So we start with what is a photovoltaic cell. A photovoltaic cell or a solar cell is an electrical device that converts the energy of light directly into electricity. Or in other words, a photovoltaic cell or a solar cell is a cell which convert light energy into electrical energy. These photovoltaic cells are generally made from silicon semiconductor and they are sensitive to photovoltaic effect. This photovoltaic cell is a key pillar of future sustainable energies. This photovoltaic cell generally consisting of a PN junction diode. This PN junction diode is the heart of the photovoltaic cell. This PN junction absorbs the light and it releases the electrons and volts, which are responsible for production of electricity. So, with the electricity produced is then applied to the load. The efficiency of the silicon photovoltaic cell completely depends upon the crystallinity of the silicon used. Like there are three types of crystalline silicon materials: amorphous silicon material, crystalline, polycrystalline silicon material, single crystalline silicon. The efficiency of amorphous silicon solar cell is less than 10%, whereas the efficiency of polycrystalline silicon solar cell is 14 to 18%. And the efficiency of single crystalline silicon solar cell is around 25%. The efficiency and the amount of power output of the photovoltaic cell is completely depends upon the three parameters. The first one, the type of material used. So what is the semiconductor material used for the PN junction? And also the solar cell, the area of the how much area is exposed to the light. So it depends upon the, these are is the parameter to get the amount of power from the PV device. These photovoltaic cells, the amount of electricity is vary with the intensity, or in other words, the efficiency of the photovoltaic cell varies with the intensity of the sunlight. Because sunlight intensity is not uniform all over the day. From morning to evening, the intensity is varying. So at the same time, the efficiency of the solar cells also vary. And the wavelength of the sunlight also important parameter to get a maximum efficiency for photovoltaic cell. The practical applications of this one is why photovoltaic cell, or the real question is why photovoltaic cells we are studying. So photovoltaic cells convert solar energy into electrical energy. What is the need of conversion of solar energy into electrical energy? In order to understand this concept in a better way, so we need to know the energy resources. So we know that energy is an important aspect of our life. Without energy, we cannot live. We cannot imagine the world without energy. So these energy resources available in this universe can be broadly classified into two categories. First one, non-renewable source of energy. Second one, renewable sources of energy. Non-renewable sources of energy. The energy resources which get depleted on continuous usage and which cannot be reproducible are called non-renewable sources of energy. Example, fossil fuels, like in that, so charcoal, coke, coal gas, water gas, petrol, diesel, kerosene. So these are the examples. Along with that, nuclear energy, thermal energy. So these are the examples for non-renewable sources of energy. Now all of you know that, so what we are using this energy, the major energy belongs to non-renewable sources of energy. So after 40-50 years, we don't know what will happens to these sources of resources. Because so these are, so you take the example petrol, diesel, kerosene, after 40-50 years, these sources may be depleted or the price of these fuels may be so very high. So that time it's very difficult. You cannot imagine the world without energy. So this is the right time to find the alternative sources of energy. What are those alternative sources of energy? Renewable energy resources. So the energy resources which are reproducible as a part of natural process are called as renewable energy resources. Example, hydro energy. Hydro energy means production of hydrogen fuel, splitting of water. H2O we are splitting into H2 plus O2. H2 is hydrogen fuel. This hydrogen fuel can replaces petrol, diesel, kerosene. Already it's proven. Its synthesis of or production of hydrogen fuel is very easy. Still, we are not using this hydrogen fuel as a energy as a source because it catch fire easily. It is explosive. Since it's explosive, storage is difficult, transportation is difficult. So it needs a big iron container for storing hydrogen fuel. If there is no meaning in fixing big iron container in vehicle or some other applications. So carbon nanotubes are the best material for storing this hydrogen fuel. We can store this hydrogen fuel in a carbon container, carbon nanotubes containers. But again, one more problem is there. The cost of this carbon nanotube is very high. Scientists are trying to reduce this cost. Now, solar energy. So this energy, we know that solar energy is converting into electrical energy, bioenergy, geothermal energy, wind energy, means wind is converting into electrical energy. So these are the renewable sources of energy. Among all these energies, solar energy plays on the top of the list. So because this solar energy available everywhere. The solar energy available in abundance. And moreover, it's a clean energy, pollution-free energy, eco-friendly energy. Right? So there is huge amount of solar energy is there. There is a huge amount of sunlight with, reaching the Earth's surface, but we are not using properly. The sun radiation that reaches the atmosphere is just a minute fraction of this sun's energy, equivalent to 1 into 10 to the power of 15 watt. A part of this is observed by Earth's surface, including land, oceans, biomass, which is estimated to be around 385 million exajoules per year. 1 exajoule is equal to 10 to the power of 18 joule, or equal to 287 billion kilowatt hour. And so as per the survey, if you are able to convert 1 day sunlight energy into electrical energy with 100% efficiency, it is sufficient to meet energy requirements of whole world for 1 year. I'm repeating, if you're able to, according to survey, if you're able to convert 1 day sunlight into electrical energy with 100% efficiency. So what do you mean by 100% efficiency? If 100 photons are falling on solar cell, out of 100 photons, 20 photons are able to convert into electrical energy. Then the efficiency we are calling it is 20%. If out of 100 photons, 15 photons are able to convert it into electrical energy, then we are calling it as a 15% efficiency. One day sunlight, we are converting into electrical energy with 100% efficiency. So that energy is sufficient to meet the energy requirements of whole world for 1 year. You can imagine how much amount of energy is there, sunlight energy. Still we are not using this energy. Why? Because we don't have any device which convert sunlight into electrical energy with 100% efficiency. What we are using, the solar cells or the photovoltaic cells today, the efficiency only restricted to 15 to 20%. So that's why, solar radiation is believed to be the only realistic alternative to fossil fuel. So that's why, there is a huge demand for the construction. So there is a huge demand for the understanding of this photovoltaic cell. So there is a huge demand for the improvement of the efficiency. So at the same time, there is a great challenge for conversion of solar energy into electrical energy. So this solar energy can be converted into electrical energy or in other forms of energy in two ways. First one is thermal conversion. Second one is photo conversion. Thermal conversion, sunlight we are converting into heat energy or thermal energy. Example, water heating. The second one is photo conversion. The light energy we are converting into electrical energy. Example is Example is photovoltaic cells. So now we'll understand the construction and working of photovoltaic cells. This photovoltaic cell mainly consists of a PN junction diode, so made from silicon semiconductor. This PN junction diode, so which is obtained by the combination of P-type semiconductor and N-type semiconductor. When P-type semiconductor is P-type semiconductor is brought in contact with N-type semiconductor, electrons from N-type diffuses towards P-type to occupy the holes. This results in electrons hole recombination at the vicinity of the junction. Yes, this region gets depleted and will not have any charge carriers. Charge carriers will not be there in this zone. This region is called as the depletion region or depletion zone. During diffusion, N region loses electrons and becomes positively charged, and P region gains electrons and becomes negatively charged. Hence, an electrical double layer is formed at the junction of P-type and N-type semiconductors. The positive charge present on N side opposes the movement of hole from P-type to N-type side. Similarly, the negative charge present on P side opposes movement of electrons from N-type to P-type side. So due to this charge separation, there exists a potential across this junction. So this potential is called as a barrier potential. So barrier potential. If you want to move the electrons, if you want a movement of electrons, you need to apply the potential greater than the barrier potential. If the applied potential is less than the barrier potential, then there is no movement of electrons. So in a better way, we'll understand the construction and working principle of photovoltaic cell. So as I said, so in the previous slide, photovoltaic cell mainly consists of a PN junction diode, so made from silicon semiconductor. So N-type silicon semiconductor, P-type silicon semiconductor are so combined with each other forms a PN junction diode. Above this PN junction diode, some metallic grids are placed, like nickel plating are placed, which acts as a top electrical contact. At the bottom, silver metal is deposited, which acts as a bottom contact. Top contact and bottom contact are connected externally through wire across the voltmeter. Above this PN junction diode, we are coating a anti-reflecting coating, so which is made from a silicon nitride or titanium dioxide layer. We are coating which prevent the reflection of solar light. When sunlight shines on the solar cell, this light enters the PN junction through the metallic grids. When the incident light has the potential is greater than the barrier potential, then electron hole pairs get separated. The ejected electrons move to N side through the PN junction. Since PN junction allows only one-way movement of electrons, these electrons must flow through the external circuit. These electrons are collected from the top contact and moved through external circuit to recombine with the holes present in P side of semiconductor. So this movement of electrons from N side to P side through the external circuit generates the electric current. So this is what the principle of this photovoltaic cell. The generated electric current directly proportional to the area of the cell exposed to light radiation. If the light radiation exposure is more, so more electric current will be produced. So at the same time, so this photovoltaic cell, the electric energy obtained from the photovoltaic cell is directly proportional to the intensity of the light radiation. It depends upon the intensity of this light radiation, which can eject the electron. So this is what the parameter which affect the efficiency of the photovoltaic cell. All methods has advantages, its own advantages and disadvantages. This method also so has advantages and disadvantages. The main advantages of this photovoltaic cell or solar energy is it is freely available. Its availability available in abundance, available in everywhere. It's a clean source of energy. It's a pollution-free energy. It is a renewable energy. It's an inexhaustible energy. So these solar cells do not produce noise during operation. So it requires very little maintenance. Initial installment of this photovoltaic cell is little bit costlier, but once you installed, its maintenance will be very little, very easy. Once you installed, you can expect this solar cell for long time, like 20 years. There is no, we are not using any fuels. So that's why cost will be so less. There is no fuel cost, fuel supply problems in this electrical energy production. So there is no need of recharging. We are using a battery for storing this electricity after conversion, but there is no need of recharging. So there is no corrosion to take place in this solar cell. There is no material to undergo corrosion. They do not suffer wear and tear as they have no movable parts. And one more important point is this power generation by photovoltaic cell can minimize dependence on fossil fuel and at the same time reduce greenhouse gas emission, mainly carbon dioxide. So these are the advantages of photovoltaic cell. The main disadvantages of this photovoltaic cell is cost. So it is little costlier during the installment. First installment it is costlier. Once you installed, so its maintenance will be very easy. Very little maintenance is required. The initial cost of purchasing a solar system is fairly high because the silicon required for photovoltaic cell is of high purity. 99.99% of purity is required. So high cost of silicon purification has resulted in higher price of crystalline silicon solar cell. So this is the reason why so these solar cells are costlier. So these photovoltaic cells are weather dependent. If the intensity of the sun varying from morning to evening, the efficiency also varies. So although the solar energy can still be collected during cloudy days, rainy days, but the efficiency will drop down. The solar energy storage is expensive, uses a lot of space. If you want a more production of electricity, you need a more number of solar cells, solar panels is required. That's why so lot of space is high. Air pollution and weather can affect the production of this electricity. So these are the disadvantages of photovoltaic cell. When you come to the so applications of these solar cells, so these solar cells are solar energy, so are mainly used in domestic purpose. So for the lighting purpose, so you can use solar water heater. We are using this one in a solar water heater. This solar energy is the main source of energy in satellites. This solar energy can be used in remote areas where electrical poles, electrical grids are not possible to fix it. So in the remote areas, we are using these solar cells or photovoltaic cell. So these solar cells or photovoltaic cells are used in traffic signals lights, street lights, in the toys, watches, calculator, in the electrical vehicles, electrical fences, water treatment, water pumping, emergency power, electric fences, remote lighting sensors. So there are many applications. So these solar cells are photovoltaic cell. So this what about the photovoltaic cell. Thank you.